and I went to go work for an investment bank on Wall Street, and I was actually in the energy group. So I've been in the carbon extraction business as well as on the other side in the climate business. And I'm going to talk a little bit today. This is really a non-technical talk. I'm going to really go over the history of climate change, because I mean, my personal opinion is that if you understand sort of how science got to where it is today, I think you'll have a lot more confidence in it. At least I did as I researched this. And I'll also weave in some of the political developments, and I think that will also help you understand how we got to where we are today. I'm going to go sort of very quickly through the first 100 years. So climate science, again, is about 200 years old. And really, the beginning is Fourier. So, you know, you love him for his series, but stay for his climate science. He's really the first person to look at the climate and say the atmosphere is doing something. He didn't understand what it was in the atmosphere, but he knew that the planet was warmer than it would be if it was a bare rock hanging in space, as he put it, although in French. Then Louis Agassiz is sort of the next big development, and I probably give him too much credit. There were a bunch of people who were working in Europe in the 1830s, and they were walking around Europe, and what they noticed was there were all of these deposits that looked like they were from glaciers. There was giant, what they call erratics. In fact, I was in Hamburg, and they have a boulder that they dredged up out of the lake. And you think, how could a boulder get here? I mean, is this giant, is probably 20 feet across. And so they hypothesized that there had been a giant ice age, and that at some point northern Europe had been covered with ice. And that's really a stunning conclusion, because up to that point, and I think it's everyone's experience here, climate is basically the same all the time. You know, the climate you've experienced is basically the same climate your parents experienced, the same climate their parents experienced. You can go back lots of generations, but geologic time is deeper. And when you go back really far, you see these things like ice ages. And this observation is really what motivated, probably for the next 100 years, most of the research in climate. Probably the next big discovery is John Tyndall, the father of greenhouse gases. So he took Fourier's analysis and said, I understand what it is that is blocking most of the infrared radiation. And it's water vapor and carbon dioxide. And so he's the person who understood what in the atmosphere was causing the warmth that Fourier had identified. And then finally, we get to sort of the grandfather of climate science, Arrhenius. So if you've taken any physical chemistry, Arrhenius factor, you'll be well familiar with this. So he got a Nobel Prize for his physical chemistry stuff. And you know, his climate stuff actually probably deserved a second Nobel Prize, because he was the first person to really calculate how sensitive the climate was due to carbon dioxide. So he actually estimated that if you added enough carbon dioxide to double the amount in the atmosphere, you'd get 5 or 6 degrees Celsius of warming, probably about 10 degrees Fahrenheit. And it's sort of a remarkably good calculation. It's probably a factor of 2 off, but given how little they knew about anything, this was really very impressive. And he also realized that humans were burning coal and that they were going to cause global warming. Of course, he thought that would take a long time. He did not understand exponential growth. As I talk to my students and graduate students all the time, exponential growth happens a lot faster than you think it is. If you know, we're designed to think of things changing linearly. That's kind of the human mind just sees linear trends. And on a linear trend, climate change would be very slow, but exponential growth is a lot faster than that. And so he missed the boat on that. And it's worth going over the things that Arrhenius got right, because it is really astonishing. So he understood temperature was determined by energy balance. And he determined it was energy balance at the top of atmosphere. So for those of you that study climate, I don't know if there's anybody in the audience, this is really the fundamental rule that we still use today to understanding the climate. He understood the infrared opacity was due to H2O and CO2. Again, Tyndall was really the first person to discover that, but he incorporated that. He understood that water vapor was a feedback and carbon dioxide was a forcing. And I'm not going to go into that. If you don't understand that, don't worry about it. But that's very impressive, actually. And I'd be happy to explain to people who don't know that. He also understood that the radiative forcing from CO2 is logarithmic. It's not linear in carbon dioxide. Again, that's a minor point, but very impressive, very impressive. And finally, he understood the greenhouse effect works by radiating at colder temperatures and by pushing the emission level higher in the atmosphere. If you want to have a good history of this, Ray Pierre Humbert, has a very good lecture, which is on YouTube, 2012 AG lecture. He goes over the history of Arrhenius and a few of the other people in there in real great detail. But it's really, in a lot of respects, everything we know, Arrhenius knew. And so if you ask the question, how old is climate science? It's not new. This is not something that was cooked up in the last year. It was not cooked up by Al Gore. It was cooked up, 120 years ago. Arrhenius understood just about everything we understood. Now, he didn't have a lot of data to back it up. And you could have reasonably told him, I don't believe all these assumptions. But it turns out he was right. And the other thing about it, though, so we'll get into sort of the politics or the social aspect of it. Back then, he thought climate change would be good. So he was a Northern European. And in those days, this is something that embarrassingly, I actually drew. This goes to show you sort of our view of humans and nature back at the beginning of the 20th century. And, back then, nature killed people. It was a battle of you against nature. If you read fairy tales, kids that wandered into the woods didn't come back. The nature was the enemy. If you hunted woods to extinction, you've improved things. If you chop down forests, replace with farmland, you've improved things. We have a completely different view today. Today, nature's a place you go on vacation if you can afford it. You want to go back to nature. You want to relax. It's good. And so in those days, nobody thought that climate change would be bad. There was no political aspect to it. It was just, we're adding carbon dioxide. The physics tells us we're going to warm the climate. And, that's what it is. And, maybe it'll be good. And so we'll talk about the transition a little bit later. So then we get to the Dark Ages, sort of 1900, 1950. There's really not a lot of advancement in climate science, so we'll go over this pretty quickly. So the one thing that did happen is there was a lot of astrophysics, and they worked out essentially radiative convective modeling for the inside of stars. Stars are interesting because they're heat sources in the center, and they emit, and they're emitting from their surface out. So it's kind of the inverse of our problem. They have convection down, then radiation up above. But a lot of the details translated perfectly to atmospheric science models decades later. There was also a debate over the importance of water vapor versus carbon dioxide. A lot of people thought, well, the atmosphere is already opaque to water vapor, so adding carbon dioxide isn't going to make any changes. And that was settled in the 50s. I'll talk about that in a second. But people still, if you go on blogs, people still say carbon dioxide can't have an effect because the atmosphere is already opaque to water vapor. Then in the 30s, the first person to identify a warming trend was Guy Callender. He was a British engineer, and he argued that this was because of carbon dioxide. Now, it's not clear he was right, but I think it is pretty clear he was the first person to say that carbon dioxide was driving warming temperatures. So Arrhenius is the first person to theoretically identify it. And then in the 30s, the first person said global warming is here. Again, I don't know if he was right or not. We don't have enough data to really attribute the warming early in the 20th century, but nonetheless, he could have been right. Al Gore was born in 1948. So just to tell you that he didn't actually invent any of this. Dr. Seuss detects radiocarbon dead CO2 in the atmosphere. And I always thought, wow, that guy gets along, Cat in the Hat, and isotope geochemist. But it turns out that it was not him, it was Hans Seuss, who is an isotope geochemist at Scripps. And the thing that's so funny is Theodore Geisel, who's the actual Dr. Seuss, lived in La Jolla, and they apparently used to get each other's mail. So that has always amused me. Anyway, Hans Seuss's detection of radio-dead carbon, what that means is there's no carbon-14. And what that means is that whatever the source of the carbon, it's been underground or it's been sequestered for a very long time. So fossil fuels is the classic example of something. If you take a pound of coal or a barrel of oil, there's no carbon-14 in it because it's been underground for so long. All that stuff is decayed away. And so when you burn fossil fuels, you add radiocarbon dead carbon dioxide to the atmosphere. And so he sort of noticed that was going up. And then Gil Plass, who I like to show a picture of because he was the chairman of the physics department at Texas A&M in the 70s. He was the person who really worked out for the first time radiative transfer to the atmosphere. And he showed that even though water vapor makes the atmosphere opaque to infrared, if you go outside and look up, you'll see basically water vapor bands. Adding carbon dioxide still has an impact on the top of atmosphere energy budget. And if you go back a few slides, you remember that was one of the things that Arrhenius really realized. It was the top of atmosphere energy budget that matters. And he showed that for the TOA balance, adding carbon dioxide does matter. And again, you still see people talking about this. I mean, 50 years, 60 years now, after this was worked out, people still say, oh, you can't, adding carbon dioxide doesn't make the atmosphere any more opaque. I mean, this was worked out decades ago. All right, so let's talk about the 50s. So the 50s is where we start seeing this shift from people thinking nature's the enemy to people thinking that we need to do something to protect the environment. And essentially, this is something called the Kuznets curve. Has anyone ever heard of that before? People seen that in economics classes? No? Nobody? All right. Well, if you haven't seen it, then you're in for a treat. So this shows this is some qualitative measure of environmental degradation. This is how rich people are. And what you see is if people are very poor, they can't really destroy the environment. If you're a sub-Saharan African, you live in a hut, you don't have any electricity, you don't have any water, you have maybe one farm animal, you can't do a whole lot to the environment. But as you start getting richer, you can really start messing up the environment. So you can have two-stroke motors, you can have large-scale industry, but without any kind of emission controls. And so if you go to China now, they're richer, but it's much dirtier. Okay, because they just don't do the things to protect the environment. So if you go to Beijing, go to Shanghai, air quality there is terrible. If you go to India, many places, air quality there is terrible. And then at some point, you get really rich, and then beyond this, you start caring about the environment, and things start going down. So I think actually China's undergoing this right now. They're beginning to care about the environment. The U.S. went through this in the 50s, the 60s. So places like Los Angeles were covered with smog. So we started regulating. And we started putting in air quality regulations, and then things started getting better. And now, if you're really rich, you can drive Teslas, and you can put solar panels in your house. You can do things that only rich people can do to help the environment. And so in the 50s, the country started turning over, and people started realizing that we had to start protecting the environment. So you have this emerging ideal of environmentalism. We also had the killer smog of London. I was watching Netflix the other day, The Crown. Has anybody watched that? The Crown. They actually had a whole episode. I couldn't believe it. They had an entire episode about the killer smog of London. So for a few days in 1952, they had an inversion. Basically, an atmospheric inversion caps the boundary layer. It doesn't let pollution go up into the free troposphere. People there burned coal. A lot of people, they just burn coal in their basement to heat their house. So you have all these chimneys belching out smoke. You have an inversion. It just sits there. As the smoke got thicker, it cut off sunlight. It got colder. People burned more coal. I mean, it got to the point where visibility was a few yards. I mean, and that killed thousands of people. Anybody with a compromised lung system, anybody who's in bad health, it could kill them. And generally air pollution was a big issue. My father was an undergrad at Caltech, 1948. He started, and he tells me the air pollution there was awful. I mean, it was really terrible. In addition, atomic arsenals. People realized by this time we had the H-bomb. We could destroy the entire planet basically, and people realized humans were powerful. We were as powerful as nature. 1957, Roger Revelle and of course Dr. Seuss had this quote, which I think is very good, so I like to reproduce it in full. So, greenhouse effect warming may become significant during future decades if industrial fuel combustion continues to rise exponentially. Human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past, nor be reproduced in the future. And so if you think about it, that's really remarkable. I mean, we're running an experiment, and we're in the beaker, okay? Think about that for a moment. How many times do you want to be in the beaker for the experiment? Well, we are in there. So the next thing, Charles David Keeling, Ralph is his son. Charles David Keeling begins Mauna Loa carbon dioxide record. And this is the famous Keeling curve. So he's measuring carbon dioxide as a function of year. Now he started doing it at 57. This doesn't go back that far, but you can just extend this back to down back here. And within a few years, you can see the long-term trend. Within a few years, he said it was going up, and it was clear that was because of humans. And that settled another big argument that had been going on the first half of the 20th century about whether all the carbon dioxide we emitted would go into the ocean. There were some people who thought none of it's going to stay in the atmosphere. It's all going to go into the ocean. And this showed that was not right. It's actually staying in the atmosphere. And so by the early 60s, we understood carbon dioxide was going up because of fossil fuels. And we had worked out, 100 years before that this is going to warm the climate. And so, I mean, I would say that modern climate science, if it didn't start with Arrhenius, it certainly was, the outlines were certainly clear by the early 60s. Now, can you hear that, or is that just off? Is it, you can hear that?
Yeah.
Okay, I can tell if it's just coming out. So let's watch this again, all right? Oops, oh, shoot.
Extremely dangerous questions, because with our present knowledge we have no idea what would happen. Even now, man may be unwittingly changing the world's climate through the waste products of his civilization. Due to our release through factories and automobiles every year of more than 6 billion tons of carbon dioxide, which helps air absorb heat from the sun, our atmosphere seems to be getting warmer. This is bad. Well, it's been calculated a few degrees rise in the Earth's temperature would melt the polar ice caps. And if this happens, an inland sea would fill a good portion of the Mississippi Valley. Tourists in glass-bottomed boats would be viewing the drowned towers of Miami through 150 feet of tropical water. Foreign weather, we're not only dealing with forces of a far greater variety than even the atomic physicist encounters, but with life itself.
So, I mean, this is 1958, and I will just make a Frank Capra joke that nobody under 30 gets. You know, I subtitled this, "It's Not a Wonderful Life." All right, so shift gears. So by the 1960s, climate science was reasonably clear. A lot of things we didn't know, but we understood the broad outlines. So let's talk a little about smoking. Because you have to understand the political debate over climate, you have to understand the political debate over smoking. So 1964, Surgeon General Luther Terry puts out a report on smoking. And this is based on 10 or 12 years of big longitudinal studies that showed that cigarette smoking is associated with all sorts of health impacts. Things that I think most of us accept today as being correct. And I mean, this goes on, lung cancer, bronchitis, heart disease, et cetera, et cetera. And so, you know, this was really well-established science. And so the question to ask yourself is, how do you think the cigarette companies responded to this? Did they say, okay, you got us, guys. This is killing people. You're right. Of course, they did not do that. What they did is they attacked basically the science. So I don't expect anyone to be able to read this. This is a memo that was, because of litigation, has been scanned and put online. And in it, so this is some lawyer for a tobacco company. This is right after the report comes out. We must, in the near future, provide some answers which will give smokers a psychological crutch and a self-rationale to continue smoking. So they understood that they have to argue about the science. And it goes on to say the answers must point up the weaknesses in the report. And this is probably the most famous example of this is this Doubt is our product memo. And this is 1969 from some cog at Brown and Williamson Tobacco. And it says, doubt is our product, since it is the best way of competing with the body of fact that exists in the mind of the general public. It is also the best way of establishing a controversy. And so, you know, this is a strategy. And we talk about environmental problems. You know, these people have the tobacco playbook open on their desk, and they're going through it page by page. And this is well-trodden territory about arguing science. You know, the Earth is warming. No, it's not. It's just like cigarettes kill you. No, they don't. I mean, it's exactly the same thing. And it works. It was able to delay action on cigarettes for 40 years. And, you know, hopefully it won't take that long. They won't be able to stop policy on climate for 40 years, but they might. So just a few other things going on. There were reports in the 1960s. So the AAAS, about a year and a half ago, actually had a 50th anniversary of this report. This is really the first report that was given to a president that says that carbon dioxide is going to lead to global warming. And then in 1975, you really had the birth of, nobody called it global warming, at least this is the first time anyone talked about global warming. So this is a paper by Wally Broker. And it's really a stunningly good paper. If you want to look back and you want to see what real a lot of papers are very incremental. This was not an incremental paper. It's very impressive. And in it, he makes a prediction. So these blue dots right here are what he said the historical temperature record was. And he didn't have a lot of data, but he kind of put together his own temperature record. These red dots are what he said the predictions were for the coming few decades. Each dot's a decade average. This is year on this axis. And this is temperature anomalies. You don't have to worry about what that means. Just departure from a mean. And this black line is a modern temperature reconstruction. This is the NASA GISS temperatures. And you can see his predictions were basically spot on. And he made that prediction in 1975. And predictions are the gold standard of science. If you can make a prediction that is not obvious, then you really proven that you understand something about the climate system that other people don't understand. And he made a very successful prediction here. And there were a lot of predictions that were made around this time that have since been borne out. Predictions like the stratosphere is going to cool. That's been observed. Predictions northern hemisphere is going to warm faster than the southern hemisphere. That's been observed. There were many, many predictions that were made at this time that have later been borne out, which suggests, again, that there's something fundamentally correct about our theories about climate change. Now, at the same time, there was that you now hear people say that in the 70s, people were saying it was cooling.
Okay, let's talk about having humility. I read this morning a Newsweek article from the 1970s talking about global cooling. And it said the science is clear. It is overwhelming. We are in a major cooling period, and it's going to cause enormous problems worldwide. And the solution for all the advocates in the 70s of global cooling was massive government control of the energy sector, of our economy, and aspects of our lives. Now,
all right, so none of that is right. I mean, maybe he was reading Newsweek this morning. That may have been the last thing he said, but I kind of doubt it, frankly. So as you can see, there was not a consensus that the globe was cooling. And in fact, the exact opposite. That 1965 report was about carbon dioxide causing warming. Wally Broker's paper, carbon dioxide causing warming. And there was nobody suggesting at the time, at least as far as I know, that they were saying that people were saying we should have government intervention because of that. That fits. It's a alternate reality that fits a general worldview, is what he's espousing. Now, there were people who were saying that the dominant direction of human influence was cooling, but not very many of them. And in fact, there was even a paper written where people went through the literature and they actually looked at the scientific literature to see how many papers talked about warming versus cooling, and they found that most of them talked about warming. There were a few people who were talking about cooling, but not very many. All right, so there are more research reports. I would say if you're interested in this, this report right here is very famous. This is called the Charney Report. You can just Google Charney Report, it'll come up. And this is really the first assessment of our knowledge. And they basically came up with this 1.5 to 4.5 degree equilibrium climate sensitivity range that we're still stuck with.
All right, so let's go back to cigarettes. So now it's the 80s. So it's been 3 decades since people actually realized that cigarettes were causing cancer. So let's look at what they were saying.
Yesterday, the government released a new report on smoking and health, which said that there is overwhelming evidence that cigarette smoking causes lung cancer and is a major factor in heart disease. The tobacco industry says that there is no conclusive evidence that smoking causes cancer or heart disease. Yesterday we discussed this new report with the United States Surgeon General, Julius Richmond, and John Pinney of Health, Education, and Welfare. And this morning Bill Dwyer, who is Vice President of the Tobacco Institute, is with us, and Steve Bell joins our conversation from Washington. Good morning, Mr. Dwyer.
Good morning, David. Thank you very much.
But if everybody made the choice to quit smoking, then of course there wouldn't, let's say, be any more tobacco industry. So it's in the interest of the industry to keep people smoking if they're going to continue to make a profit. Why should the public believe you as opposed to believing the Surgeon General and all the doctors and the reports from government?
David, I don't think it's quite so much a matter of believing us versus someone else. It's believing what the facts are. And the facts shouldn't all come from a single source. It isn't really just our statement of contradiction or difference with the Surgeon General. There are many independent men and women of science who don't believe that the causal conclusion yet has been reached. David, we don't deny that there is statistical evidence. Smokers in greater number than non-smokers do fall victim to these various diseases, but we must remember that, for example, most smokers don't develop lung cancer, and certain non-smokers do as well. We think it's an open question.
So again, you can begin to see the outlines of the kind of arguments people use about climate change there. You know, it's the facts aren't all in. There's disagreement among the experts. And that was not true then. I mean, among the sort of the experts, the epidemiologists who studied this, it's 30 years past the time when they realized the science is really settled of cigarette smoking. All right, so 1985, ozone hole. I'm going to go through this kind of fast because I don't want this to go too on. But the 80s is really when things started changing. So 1985, ozone hole. 1988, Montreal Protocol on ozone depleting substances. This is the agreement that essentially phased out the chemicals, the CFCs, chlorofluorocarbons that were causing the ozone hole. And 1988 was also the year that global warming really became a political issue. There was famous testimony in the House by Jim Hansen who said global warming is here and it's due to humans. I think when he said it, he was really out on a limb, but I think he's been proven to be right. He's right. And he'll get a lot of credit for that, although it could have gone either way. I think he didn't have a lot of evidence to say that at the time, or the evidence was really limited. There was also, again, a growing environmental movement. And again, that's just a continuation from the 50s of this idea that the richer we get, the more people care about the environment. And it was getting more and more important as a policy advocacy group. And then 1988, the IPCC was formed. And this was basically formed because of the ozone hole. So during the ozone hole, there were a number of very influential assessments of ozone science by the World Meteorological Organization. And those worked very well to push policymakers to stick to the science when they made their regulations. People thought, well, we need the same thing for climate, so let's generate a body that assesses climate science. And that's what the IPCC does. Now, at the same time, I started graduate school in 1988. And, so this is really a pivotal time. You never understand you're in a pivotal time until, decades after that. But I now realize that was this pivotal time. We're working on the ozone hole. Climate change is going to be an issue. There may never be another time in environmental science quite like that. So then 1988 is also when climate skepticism was born. There was really very little people arguing about climate science until climate became a political issue. And then once it did, all of these people came out of the woodwork to dispute the science. Because again, that's a tactic. It's not something that arises because people have actually looked at the science. They do it because it helps you win the political argument that you're trying to make. And in fact, I should say, part of this is, so when you look at the underpinnings of this, part of it is that 1988 was also the time that the Soviet Union fell. So the people, the Cold Warriors who had defeated the Soviet Union, looked around, they said, what's the next great force in society that's going to take away our freedom? And they said it's environmentalism. And you can see that explicitly made in these jokes. So this is a book by James Delingpole, who writes for Breitbart now, called Watermelons. And so the joke about a watermelon is how are environmentalists like watermelons? Well, they're green on the outside, but they're red on the inside. And by red, he means communist, as you can tell by the hammer and sickle up here. And so quite clearly, there's a view, and it's actually expressed explicitly by Václav Klaus, who is president of the Czech Republic. People know that?
No.
Then maybe it's Slovak. He was president of someplace in Eastern Europe. I'm an American, so you don't expect me to know that. And basically what he says is the largest threat to freedom, democracy, the market economy, and prosperity at the beginning of the 21st century is no longer socialism. It is instead the ambitious, arrogant, unscrupulous ideology of environmentalism. So can somebody Google that? Václav Klaus, figure out what?
President of the Czech Republic.
Oh, it is Czech Republic. All right, so I was actually right. All right, good. All right, so this, he makes it explicit that environmentalism, they are the enemy. They're the people who are going to take away your freedom. And if you think about it, if you honestly believe that,
then you do have to fight them. If you think they're the next evil empire that's going to take away your rights, going to start ruling your life, then yeah, I mean, you would have to fight them. I don't think that's correct. I think you can be an environmentalist without wanting, to live under a communist regime. But still, there are people there that's what they thought. And so these people that came out. Were many of them were it wasn't just the same arguments as it was in the tobacco debate. It was the same people. So Fred Singer, if you follow this at all, you've heard of him. Actually, I know Fred quite well. He's actually come to A&M and given a lecture to my class. So here he is on secondhand smoke, and I don't read it, but he just doesn't believe it. He thinks it's junk science. Oh, you can't, the statistics are terrible. You can't believe anything they say. Here's Fred Singer on acid rain. Oh, you can't believe that. Here he is on nuclear winter. No, you can't believe that. Here he is on ozone depletion. I don't have to even tell you what he says about that. He doesn't believe that. And of course, here he is on climate change. So it's really a very small group of people that have any kind of scientific credibility that are willing to dismiss this stuff. And in fact, if you look at these congressional hearings, we just had one a few days ago, it's always exactly the same people who represent the side trying to tell you the science is murky. Okay, there's a very small number of people. They're endlessly recycled. Recycling of bad experts is the only environmental thing these people do. So it's a very thin bench. It's a very thin bench of this argument, but it does work. It does work. Just very quickly, because I'll get to more interesting stuff in a second. Earth Summit produced a framework convention on climate change. This is really an extremely important document. Everything we do now is under the aegis of that. Kyoto Protocol. When I used to give this talk, say 7 or 8 years ago, I would talk a lot about the Kyoto Protocol. Now it's entirely irrelevant. I'm just going to say it existed. Climate science was advancing rapidly in the 1990s. In 2001, the IPCC had their statement, which is there is new and stronger evidence that most of the warming observed over the last 50 years is likely attributable to human activities. So you go from earlier statements that we're not sure the balance of evidence supports a demonstrable impact or discernible impact to now really very clear statements that humans are now the dominant driver of climate change. We have our foot on the gas when it comes to the climate. George W. Bush takes office, U.S. withdraws from Kyoto, and then we get to sort of something which is more relevant to us. So in the early 2000s, a bunch of environmental organizations got together and petitioned the government to regulate carbon emissions from cars under the aegis of the Clean Air Act. So the Clean Air Act goes back to Eisenhower, and it was amended in Nixon administration to basically clean up the air. It's the reason why in Houston and Los Angeles, these places, the air is clean. It's because of the Clean Air Act. And so they petitioned the EPA to declare basically carbon dioxide a pollutant and to regulate it. So the EPA declined to do that. And they gave two reasons. Number one, the Clean Air Act does not cover greenhouse gases. They said it is not a pollutant as covered by the Clean Air Act. And they said even if it did, we still wouldn't regulate it. And it wasn't 100% clear why they said that. It may have been they thought science was too settled. It may have been they were deferring to Congress, like we think Congress should give us explicit instructions. But they basically said they weren't going to do it. We don't think it applies, and if it does, we're still not going to do it. So then came the famous, then came the response that always happens in America: you sue them. And so Massachusetts, plus a bunch of other states, plus some cities, sued the EPA and said you cannot do that. You cannot simply decline to regulate greenhouse gases. And this actually went to the Supreme Court. And 2005, first it got upheld. The EPA was upheld by the U.S. Court of Appeals for D.C. Circuit. But they had a really convoluted ruling. And the judges, even though the judges kind of voted to uphold it, they didn't have consistent logic. And so it went to the Supreme Court. And in 2007, very famous Massachusetts versus EPA, the Supreme Court sided with the plaintiffs. And they said that the EPA had to regulate greenhouse gases if they were found to be dangerous. So if they were found to be a pollutant, they had to do it. And I'll talk about that in a second. Then same year, IPCC's fourth report, again, strengthened our idea that humans were the dominant driver Now it's very likely. Before it was just likely. And so it's used to go back a second to the endangerment finding. So essentially, after the Supreme Court ruled, that it went back to the EPA to make a decision about whether CO2 is a dangerous pollutant. Because the Supreme Court said, if it is, you must regulate it. So it goes back. This is the Bush EPA. And again, here's the definition of pollutant. Causes, contributes to air pollution, which may reasonably be anticipated to endanger public health or welfare. So this is a different definition. Most people think of air pollution as something you can kind of see, like a hazy day. This is different than that. It's anything that endangers public health or welfare. And if so, if it fell in this definition, the EPA was obligated to regulate. So we went back to the EPA, they looked at it, and their lawyers said, of course, carbon dioxide is a dangerous pollutant. This is the Bush EPA. There's no question. It is a dangerous pollutant. And so they put the report into an email and they sent it to the White House, and the White House refused to open the email. They basically said, we are never going to open this email. All right? And now this is June of 2008. So Bush is still president, but he's playing cards and he's painting. I mean, he knows he's going to be out of office because they're going to get sued because of this. But he knows he'll be out of office before that lawsuit works its way up. So they just say they're going to do nothing. They will do nothing about this. So then 2008, Great Recession hits. Gingrich, so at this time, this is very interesting. So up until Obama was elected, you had Republicans who believed that climate was something we should deal with. And probably the epitome of this is this ad I'll show you with Newt Gingrich and Nancy Pelosi.
Hi, I'm Nancy Pelosi, lifelong Democrat and Speaker of the House.
And I'm Newt Gingrich, lifelong Republican, and I used to be Speaker.
We don't always see eye to eye, do we, Newt?
No, but we do agree our country must take action to address climate change.
We need cleaner forms of energy, and we need them fast.
If enough of us demand action from our leaders, we can spark the innovation we need.
Go to wecansolveit.org. Together, we can do this.
So if you think about it, that's really unthinkable. It's unthinkable that would happen today. And then in the election, both McCain and Obama, who were running for president in 2008, both of them supported cap and trade to reduce emissions. Their arguments were arguments that just in the weeds, like how do we give away permits? Do we auction them? Do we allocate them? How much nuclear do you use? How much should you reduce emissions by 2050? Should it be 80%? Should it be 60%? Arguments that would be unthinkable today. Today it's a hoax. That's the argument you have, not these arguments about this. And then Obama was elected, and really everything changed at that point. That's really the moment when Obamacare's signature healthcare law becomes law. Waxman-Markey, which is a climate bill, also called ACES, American Clean Energy and Security Act, died in the U.S. Senate. And this is when the Tea Party rose, and climate became a litmus test issue. So starting in 2009, in order for you to be a Republican, at least a Republican office holder, you, with almost 100% certainty, you had to dismiss the threat of climate change. That was not true before 2009, but that was true after the rise of the Tea Party. All of the moderate Republicans got wiped out, basically. And anybody who viewed, Bob Inglis is a well-known former congressman from South Carolina who believes in climate change. He got primaried, and he was beaten by Trey Gowdy. Anybody know who he is? So, he looks like Draco Malfoy from the Harry Potter movies. Anyway, but at this point, from this point on, if you became an office holder, this was a litmus test issue, kind of like, lower taxes or something. Now, there are lots of reasonable Republicans, like Jim Baker. We all know who Jim Baker is, but they're all out of office because they don't have to get elected, and they're not worried about getting a primary. Again, Copenhagen Meeting and Kyoto Protocol. I used to talk a lot about those. Those are wholly irrelevant now. So 2012 to 2017. This is why I talk a lot about the Clean Air Act. Essentially, everything Obama has done or did was through the Clean Air Act to regulate emissions. And that makes the Clean Air Act sort of ground zero for climate battles in the future. And I think the Republicans will very likely try to congressionally strip greenhouse gas authority from the Clean Air Act. Because it will take a law for them to change the Clean Air Act to explicitly say it does not apply. Because the Supreme Court has already said, as written, the law does apply to carbon dioxide. So that's settled law. So so this is really going to be an interesting battle over that. Then 2013, fifth IPCC report. It's now extremely likely that humans are now the dominant influence of climate on long time scales. We don't affect the climate year to year, but on decadal and centennial time scales, we're now the driver of it. So 2014, I'm getting very close to the end. U.S. and China sign a bilateral agreement to limit emissions. I think this may, in the end, be one of the turning points of policy. Before this, the developed world was always a stumbling block for policy because their attitude was, why should we limit our emissions? You know, you guys emitted all the carbon that's in the atmosphere, and you guys got rich doing it. We want to be as rich as you, and the only way to do that is for us to grow and consume energy. So this became a big fairness problem. But with China has other problems. They have air pollution problems, other things that cause them there are a lot of other benefits for them limiting their emissions. Plus, they're very vulnerable to climate change. So they have a lot of engineers running the country. So they realize it's something they want to do. And so they signed an agreement to limit emissions. And then that really led the way for the Paris Agreement, which is December of 2015, where all the countries of the world put forward plans of what they were willing to do. It's a little different than the Kyoto Protocol. It's sort of a bottom-up agreement instead of a top-down one. The U.S. intends to achieve an economy-wide target of reducing emissions by 26 to 28% below its 2005 level in 2025. If you wonder why they picked 2005, that was the peak emission year. So it gives them the easiest job. Emissions have basically been going down since 2005 for the U.S. And then, again, all of the support was through Clean Air Act regulations. So then 2017, Trump takes office, and you think, what a difference a year makes. We're not spending, this is Mick Mulvaney as the head of OMB, Office of Management Budget. We're not spending money on climate change anymore. It's a waste of your money. And so somebody tweeted out, if you know a lot about IPCC model runs, this is a funny joke. If you don't, it's not funny. But so I will not explain it. If you don't get it, don't worry about it. But we all laughed. I laughed when I saw that. So we're basically not doing anything at this point. They're trying to undo all of the Clean Air Act regulations that Obama was doing. It's unclear what's going to happen, to what extent Trump will be able to do it. I think it'll take several years. So a lot of it will depend on who gets elected in 2020. If it's another Republican with similar policies, I think their chance of really rolling back policies is a lot greater. If it's Democrat, then there may not be as big of a rollback. Now, you might say, well, this is pretty pessimistic. But the thing that does encourage me is this plot. And this is the price of renewable energy. And this is wind cost per kilowatt hour. This is price of PV solar. This is per watt. So these are actually different units. But don't worry about that. The point is the price is really declining rapidly. And it may be that at some point soon, renewable energy becomes so cheap, especially if we get battery technology, that we will switch to new energy sources without any government policy. That's kind of always been the dream of Republicans, at least, that, why don't we just let the free market take care of this? Well, maybe the free market will eventually. I think there are real flaws with that argument, but I won't go into that. And so, this might end up, saving our bacon. So I'll just conclude with a few conclusions. I mean, we've been working on this for about 200 years, and we have a very good theory of climate at this point. We don't understand everything, but we understand a lot about the climate system. We've made lots of predictions about climate, a lot of very successful predictions. Again, that's the gold standard, that you understand something, is if you can make predictions that are not obvious. I think the risk from future climate change is significant. I didn't talk about that at all, but I think that there's a lot of evidence that a few degree warming is really going to change the planet as we see it. It's a lot more than you think it would be. You think a few degrees wouldn't matter, but your intuition fails for the global average. And arguments over climate science are really proxy arguments over policy, basically, just like they were in tobacco. Those were not legitimate arguments about science. It was a strategy to win a policy debate. And the arguments over climate are exactly the same thing. Nobody who says climate science is bad actually understands climate science. Lamar Smith does not understand any climate science. He's a lawyer. He has not researched the science. Okay, he's doing it because he has a policy argument he wants to win, and this is the way he does that. So anyway, I'll wrap up there. I think I went a few minutes long, but not too bad. And I'm happy to answer questions. Thanks.
Appreciate Professor Dessler left about 12 minutes for questions, so lots of time for questions from the audience.
Just today, I was reading a story that China may take the lead now under the new regime here in America. What do you think about that?
Yeah, I think in 2006, back when Republicans would listen to climate science, I got invited to go to Austin to give testimony before a House committee. And I said to them, look, you have a choice. We can develop technology and sell it to China, or we can not develop technology. We can buy it from China. I said, which one do you want to do? And it turns out they want to buy it from China because that's what's going to happen here. I mean, we are ceding international leadership to them, and we're ceding technological leadership because technological leadership comes with government policies. People right now, there's no incentive for you to develop. If you think there's never going to be regulations on carbon emissions, why would you invest any money in doing research and development on carbon-free energy? Just burn coal, And so I think we are really we're really seeing the diminution of America in climate, in addition to all sorts of other fields. But we're really getting smaller on the world stage.
But would China's efforts be enough, do you think?
Will China's efforts be enough? I think that eventually, I don't know when, but eventually people were going to realize, just like smoking, there came a point when the tobacco companies couldn't keep arguing that they didn't kill you. And I think at some point everybody's going to agree that the climate scientists were right all along. I mean, maybe it'll be 2040, maybe it'll be 2060. Hopefully it'll be 2020 or something. And at that point, everybody will get on board. And the question is who's going to be the leader of that, the technological leader? And I think it's going to be Europe, it's going to be China, and we're going to be buying a lot of their equipment from them. You want me to call people? Or?
Yeah.
Yeah.
Fred Singer spoke at Rice several years ago, and I'm thinking about maybe sometimes it is worth listening to the skeptics out there. Look for the wheat and the chaff, even though there's a lot of chaff. But he said two things that really stood out. That he said one was that the ocean temperatures are not being correctly measured, and they need to be corrected. The other one was that we still have a real difficult time understanding what's going on with the water vapor in the upper levels of the tropical troposphere, which leads to, poor understanding, and that is our largest source of IR going into space. Now, it seems to me, I thought the ocean thing, I thought, that's all been settled. Now we have Thomas Carl come out and say, no, we did get it wrong. And he never put it in there, but basically said Fred Singer's right, that, in fact, there were errors in it, and then he corrected them. In that science paper. And I'm wondering now the same thing. Is Fred Singer right that we don't understand and models don't correctly predict what's going on in the tropical troposphere?
Yeah, okay, so first of all, I don't think anybody's ever said Fred Singer's right in the climate science community.
But Thomas Carl didn't admit it, but
Oh, yeah, he did not admit it. All right, so, yeah, okay, so we can talk about that. So when people say, you don't know everything, let's think of an analogy. All right, so when it comes to cigarettes and smoking, I can't tell you how many packs of cigarettes you have to smoke before you get lung cancer. I can't tell you why this person smokes 1 pack a day, gets lung cancer. This person smokes 4 packs a day, doesn't. I can't tell you why this person who doesn't smoke doesn't get lung cancer. I can't tell you what there are lots of things I cannot tell you, but I can still tell you these broad outlines of cigarette smoking. The same thing's true with climate. Now, for the examples you provided, I think those are not even legitimate uncertainty. So water vapor in the upper troposphere, that's well understood, extremely well understood. If he'd said clouds, he would have had a more legitimate argument, but not water vapor. That is completely wrong. Measuring ocean temperature, no data set is perfect. If you take any data set and you say there's a mistake in there, it's right. And these people are always revising their data. And every time they revise the data, it doesn't mean, well, we didn't know anything before, now we do. It was really, the revision that Thomas Carl put on that was tiny. If you plot all the data sets up, it's barely the width of a line. I mean, all that matters is the trend over the last 10 years. That's essentially what they're arguing about. But they're not arguing about the warming over the last, the warming over the last 100 years is really well established.
But how could, if it's so tiny, how could that erase the hiatus?
You know, I'll tell you, I am sympathetic. I am sympathetic to the skeptics. I think in the sense that I think the hiatus is a dumb thing to argue about. It's short-term variability.
Yes, it is.
You know, let me put it this way: if you have a time series that kind of looks like that, and then you look at just like one period, and it looks kind of like, it's going to look like that. You say, okay, I'm going to start here and I'm going to end here. Whoa, I have a negative trend. Climate change has stopped. The hiatus is entirely a function of the fact that it's a short time period, global warming is slow, and your internal variability is large. So these ups and downs are not forced. They're internal variations, things like El Nino. And so so these are completely unrelated to climate change. It just so happens 1998 was the biggest El Nino of the 20th century. And so they're starting a really hot year, and then you end in a very cold year. And so, so the hiatus is it's a completely, it's like, imagine you went somewhere and you found an island of people who smoked all the time and never got lung cancer. That doesn't overthrow your theory that lung cancer is bad for you. All it does is you've learned something interesting. Let's study why these people don't get lung cancer. It doesn't cause you to question the theory. And so the hiatus is not a threat to our. It's just these very small changes over short periods of time. The revisions do matter, but they don't matter on long time scales.
But the IPC spent like 4 pages of agony on
it. I know, because it was a big issue, because that's what people were talking about, and they have to talk about that. If they hadn't talked about it, you would have said whitewash. It would have been.
Good point.
Yeah.
I think this is probably the most perfect presentation I've ever seen.
Just stop right there. All right, thank you. Next question.
It's probably the most perfect presentation I've ever seen that shows why today's global warming alarmists believe what they do and the least amount of data. I would like to see the hands of the people in here who think that that we're controlling the temperature of the Earth. Can I see the hands, please?
Controlling, that's well, yeah.
Okay.
Affecting it would be a better.
Thank you.
Some students ask questions.
Yeah.
Do you have any data besides the political arguments that you presented as to why we should believe this?
Oh yeah, I mean, look. Let me.
One chart.
Yeah, let me explain. Let me explain to you.
I want to understand how the science differentiates between the other factors that push global warming or cooling, like the sun's temperature,
right?
Variations in the sun's temperature,
sure,
or variations in the planet's orbit,
right?
All of which have huge effects on the climate, and how you differentiate the CO2 in the atmosphere from those force functions. And how you explain the dozen or so ice ages in the last, or small ice ages, in the last 200,000 years.
Yeah. Okay. So that's a good question. So let me begin by asking about why I didn't talk about science, because that's a good question. And I used to go out and I would talk about infrared, sigma T to the fourth. I talk about emissions levels, and the bottom line is that doesn't convince anybody. Because if you come in here and you think climate change is a hoax, nothing I tell you is going to convince you. I guarantee that. I have spent many times talking to people. And so I found that it's more useful to talk about the context of the debate than talk about science. I mean, there is an unlimited amount of websites, and read the IPCC that will explain the science if you're truly interested in understanding the science. Now, about your specific question about detection attribution, that's an excellent question. I go over that in some detail in my class. And I'm happy to answer that in any level of detail you want to know. But why do we think it's carbon dioxide? So you can write down all of the things that you think cause climate change. All right, so you can say it's the sun, solar output. You can say it's orbits, it's orbital variations, okay? You can say it's internal variability, things like ENSO. You can say it's CO2. Okay, you can write down, those are basically, you can say maybe it's tectonics. So it's maybe tectonic action. Now, you can go through there and you can eliminate all of the cases. So it's the sun. Well, it cannot be the sun because we're measuring the output of the sun. The sun is not getting brighter. In addition, if the sun were getting brighter, the stratosphere would warm up. Okay? The stratosphere is not warming up. The stratosphere is cooling off. That's a fingerprint of CO2. It's not a fingerprint of the sun. So it's not the sun. Orbital variations. The orbit does vary, and that's what causes the ice ages. The orbital plus a CO2 feedback. But the orbit varies slowly. This is a 10,000, at fastest, 10,000 year effect. Orbit has not changed in the last 100 years to any extent that can change the climate. So we can eliminate that. Internal variability. It's very hard to eliminate that, but nobody has a theory that says that it's sort of like a super ENSO. And then you have CO2. So CO2 is like the suspect in a crime that dropped their wallet at the scene. They were videotaped carrying the stuff out. The stuff was found in their trunk. They were bragging to their friends about it. The amount of evidence that supports carbon dioxide is overwhelming. We have theoretical arguments that if you add
carbon dioxide, what percentage of all the constituents in the atmosphere is carbon dioxide?
It's 400 ppm, parts per million. All right, so let me finish answering your question. I don't want to get off track. I want to finish answering your question.
Well, I think you are getting off track quite a bit. But
wait, okay, let's talk. I will argue.
Percentage of carbon dioxide in the atmosphere is what?
It's 0.04%.
0.04%.
Right.
0.04% of the greenhouse gases.
No, 0.04% of oxygen plus nitrogen. Now, all that tells you, see, people always make that mistake. All that tells you is how much oxygen and nitrogen there is. If you removed all the oxygen and nitrogen from the atmosphere, you wouldn't change the greenhouse effect at all. All you would do, but carbon dioxide would go up to be 100%. And so the percentage, all it tells you is how much oxygen and nitrogen. It doesn't tell you anything about the warming effect of carbon dioxide. I mean, that's a rookie mistake that people make. They think because the number is small, that means something. It doesn't. So let me just finish answering your first question.
Sure.
Carbon dioxide, we have an enormous amount of evidence. We have theoretical evidence that says that if you add an infrared absorber, you should warm the climate. We know that we're adding an infrared absorber in carbon dioxide. We know the climate's warming. We know it's warming about as much as you would predict from carbon dioxide. So if you were on a jury, you would vote to convict it. You would. It's beyond a reasonable doubt, not beyond a shadow of a doubt. But the standard for a jury is a reasonable doubt. They're certainly reasonable. It's beyond a reasonable doubt. Tectonics is too slow.
What if, get back to the orbital perturbation there, and I'll cast some reasonable doubt, at least in my mind. So there's been a bunch of ice ages, and you say it's due to the orbital change. Distance of the Earth, average distance from the sun changes. And that makes sense.
Also the tilt to the planet and the precession of the equinoxes.
Yeah, all of that. And you say, well, you cross it out because that is a cycle that's on a 10,000-year basis, right?
That's right.
You eliminate it. But during that 10,000 years, there's 10,000, 5,000 years.
He'd ask you to wrap up the question.
Sure. There's 5,000 years when it's going up. And 5,000 years when it's going down.
Oh, it's actually a 23,000-year cycle. 10,000 is the half period,
okay.
Sorry.
So
it's 10,000 years is going up, 10,000 years is going down.
If we're in the cycle where it's going up, naturally we would see warming now, whether there's CO2 or not, right?
Yeah, but I mean, this is a physics problem. It's not a correlation problem. So I would ask you to show, I can show you that carbon dioxide should warm the climate, and I can make a prediction about how much. I would say you take the orbital variations and you do the physics and you explain a 0.8 degree rise over the last century, and you cannot do it. People have done that calculation. Scientists are not idiots, okay? We have worked all of this out. It is not the case like you haven't thought about this. No, we have thought about it, okay? We have thought about it. We have worked this out.
But what makes me
Okay,
skeptical?
it's 3 o'clock, and so we're going to wrap it up and bring it over cupcakes and drinks here and encourage students. Professor Dessler is very accessible.